Okay, so hi guys, it's the day 13 of doing Leetcode daily until I get a job. So let's start with the questions today. We have the graph series here, and we are starting with the graphs today. We'll do these questions, and let's start with the first question. Some of them are logged, so we'll skip them. We are not going to buy the Leetcode premium here. Okay, so number of islands. Given a M by N 2D binary grid which represents a map 1 and zeros there. Okay, 1 means the land, 0 means the water. Return the number of islands there. So basically number of island means the connected ones. Okay, and all the connected ones where we can go from one to another one that forms an island. Okay, so there's only one island in this because these ones are connected. These 6 ones, then this, or we can go to all the ones from any of the one. Here there are 3 islands, like these 4 creates one island, these 2 create one island, and this single one create one island. Okay, so this is the way of doing it. What we can do is we can simply apply the DFS, and we can go to any of the one. When we are at any of the one, we can start DFS from that element, and we can explore all the possible ones where we can reach from there, and we can mark them as true or maybe mark them as zero, that this is already counted in one of the island, so we don't have to explore them again. Okay, and at the end we can return just the count which we are keeping track of. Okay, so it's simple. We'll just n, that is the grid dot size, then m grid 0 dot size. Okay, and then after that what we are going to let's take a variable int count 0. Count will be our final answer which will be returning. Okay, then next thing is that we are going to go to every node once int I 0 to I less than ni plus plus, or for int j 0 to j less than m j plus plus, and we will go to every node, and what we will check is that if grid I j is 1, only then we will explore it, right? If there is already water, why will we explore it? Because we are searching for the island only. So if it is 1, we will do what is, we will go for the DFS of this grid I and j. Okay, and we will increment the count. Now we will write the DFS function that will return basically nothing. So void DFS, and let's copy this same here, and int I int j. Now here, firstly, if in the DFS also, like size and length, okay, and nm. Let's take the size also, we don't want to calculate it again and again. So n m and n and n. Okay, so what we are going to do here is that firstly is there is a condition. Okay, if I is less than 0, or j is less than 0, or I is greater or equal to n, or j is greater or equal to m, if any of this case is true, or grid I j is not equal to 1, if any of the cases here, then we will just return here. Okay, we will return, and else if this is not the case, then we will make the grid 0. Okay, then we will make the grid 0. If this is not the case, that means that grid ij is 1. Okay, we will make it 0, that it is explored and don't come here again. It is explored and the answer is counted here. Okay, it is already counted in a in island. Don't count it again. Okay, and we will just go in all the direction of that particular node now. That from here where we can go up, down, left, and right. There, these are all the directions we can go from this, right? So we will just do, right, call the same function for grid. Let's say I plus 1 j m n sorry, n m. This is actually for the I plus 1 direction, means the next row. Okay, the bottom row. So we are gonna do this for all the four direction. All the four direction means, firstly, next we are gonna do go here. Once we are gonna do this, and next we are gonna do this will do the thing that we are traversing in all the four directions of the current node and searching for ones. If there is a one, we will just put it at 0, because this is a indication that we have counted this node already in a island. If it was 1, it was 0, then doesn't matter. Okay, we will just return the count here. This is the number of island. Okay, let's see if it's working. Yeah, it's good. Submit. Fine, we are good with it. Next is the max area of the island. So if you are given M by N binary matrix like the last one, and here 1 is representing land again, 0 is representing water, and in the 4 direct collective direction, you may assume all 4 edges of the grid surrounded by water. The area of an island is the number of cells with value 1 in that island. Okay, so return the maximum area of the island in the grid. It's the same question, exactly same question, no difference in this. It's just that we don't have to calculate, we don't in last question also we were traversing all the ones connected to a single one. Okay, and same we are doing here, so we can just copy some of the code from here, that is this, and here we can paste it, and the answer we will have here, let's say we will not count anything, we will just have the area, and let's initialize this area as the int min. Okay, is the island return 0, so we will just start it with 0 only, is the least we have to do. Fine, then what we can do is, if we found a 1, this should return an integer. Now this function should return an integer. Okay, it will be, okay, it will be answer is equal to max of answer comma this function, whatever this is. Okay, this will return us fine. Okay, now let's try to do this. And int I, int j, int n, int m. Okay, so what we did here was that we were traversing in all the directions, and we were just finding out. Now we have to find the area. We were just marking and them as 0. Now in this case we have to count that 1 in our area, and how we can do that is, firstly we are only gonna take the valid directions. Okay, so if I is, see, if I is in same case, same condition actually, it will be the same exact condition, we will return a 0 in this case. Okay, if I is less than j is less than okay, is not equal to 1. Yeah. And if this is not the case, then what we will do is that we will put the grid I as I and j as a 0, same as the last question. We know why. And we will return is, we have found a 1, right? If it was a 0, then it will have returned here. We found a 1, that's why we are here. So it will return the area of the current cell where we are, plus the plus area of, means the we will do the dfs returning the area actually. So plus the dfs of grid in all the directions now, j I plus 1 j n m plus dfs of grid I j plus 1 n m plus dfs of grid I j minus 1 n m. Put them both here only. N m. Okay, and lastly, last direction is I plus 1 j plus 1, I minus 1 is remaining, right? That direction is remaining. So we will return the grid I minus 1 j and n. Yeah, and we will just return the answer here. Simple as that. Okay. Yeah, so there's a solution. What is it? Okay, where is the closing parenthesis of it? Okay. Answer is max of grid I, j, and m, and okay, answer. Okay, yeah, that's fine. So there's a wrong case. We're returning 0 here, it should be 1. Okay. Output expected is 6, we are returning a 0 here. If I is less than 0, I is greater than m. Less than 0, yeah, otherwise we'll put the grid as 0. Are we actually like, they are, I don't think they are strings. Do you think? Yeah, they aren't strings actually, they are values. So we need to remove them from here. It should be 0 is equal to 1. Fine, yeah. Yeah, correct. We were taking them as string as in the last question, but they are now integers, not strings. Okay, not characters actually. So yeah, this is done. Now the clone graph. Clone graph, as we have done by the name, we have to basically return the clone of the current graph, and it is given that original graph is this. We cannot return the same original graph, right? We can, this, no, this looks like a clone. This, okay, this is a clone, we should return. This is not, we should return. The nodes are cloned, but the graph is not same as the original graph. Okay, so we need to clone a graph, and what properties are we given is that return a deep copy. Deep copy means the exact same graph. Given the reference of a node in connected and directed graph, each node is a graph containing a value int. Each node in the graph contains value int and list node of its neighbors. Okay, हर node की दो property है. First its value, the integer value it is containing, and second is the neighbors list. Okay, the list of neighbors connected to it. Like for 1, what are the neighbors? 2 and 4 are the neighbors. So this is the list. Therefore 1, 2 and 4 are the neighbors. For 2, 1 and 3 are the neighbors. For 3, 2 and 4 are the neighbors. And for 4, 1 and 3 are the neighbors. So we have the neighbors list. We have the integer value. Yeah, actually the whole graph. So we just need to create a deep copy of it. Okay, what we can do is, for each graph, for each node, we will go to its neighbors, and we have to check if that neighbor is already visited, because one node can be neighbor to a multiple nodes. Okay, and we have to check if that node is already visited or not. So what we can do is, node we can make a hash map here, hash map like this, unordered map, that will just store node to node. Okay, mp. And what we can do is, if there is no node, like it's an empty graph, we will just return null. Null is not written like this here, null. Okay, and if there is a graph, we will just, if there is a graph, see if the node, let's say if there is only one element, if the node has no neighbors, NEIGHBORS, the neighbors, nodes neighbors dot size, if it is 0, then there is no other nodes. Okay, so we will create a new node, node star new node is equal to new node. We will insert the node's value to it, and we will just return the node, right? New node. Otherwise, we will do what is, we will just return the DFS. Yeah, basically it's a kind of a DFS only, because we are marking the elements every time we go there. But yeah, it's exactly a DFS it is, because we are recursively calling that function to see whichever nodes we have seen and whichever we have not. So we'll do node and the map here. Okay, so in the node star DFS, we have two elements. First is the node star node, and second is the unordered map of node star unordered map of node star and map. Okay, and we'll reference it obviously. So we will firstly have a vector of node star v, which will be the neighbors of the current node. Okay, which will be the neighbors of the current node. So let's make the current node for, let's make a new node for the current node, that is the current node. It will be new node, and it have a value of node, which we are at currently. So we have made a node for a current node. Okay, and that is basically for the new graph. Okay, and it is the same value as we had in the old graph, so it's for the new graph, the new node. Okay, now for this new node, we will put this in the map for itself. Okay, key and value are the same. So now, okay, current we have to put that it is, map is basically used here to suggest that which elements signifies which element, like which element of the old graph signifies or means which elements of the new graph. Like node is the old element, which is same as the new element of the new graph is, which is current. Okay, so map is for this purpose only. So we will go to the neighbors of the current now. For auto IT current, NEIGHBORS, for the neighbors of the current, it's an array basically. Okay, so we'll do what is, if mp dot find it, if we find out that this node is already in the map, means this has already been visited and there is a node existing for this node. If it is already there, then that's fine. Not current neighbor, we will go to nodes neighbors. Okay, Yeah, because current is a single element for now because there's nothing connected to it up to now. Okay, if it is already there, then we will just push that in the vector that it is basically done. MP of IT, it is done. And if we cannot found it, what we will do is v dot push back the DFS of it. We will now solve for this node because we haven't made a node for this. Okay, we are exploring the old graph and we found a node which has not been made a copy of. Okay, whose copy has not been created up to now. So we will we will call the function for this node now. That will be IT and MP, right? We will create, I will push it back here, and the roots neighbors, sorry, the new node, yeah, which is current, its neighbors will be what? Its neighbors will be V, right? Its neighbors will be a vector, right? And in this vector we have already created whatever were the neighbors of node. This node will be the neighbors of this current, right? Because they are the both same nodes in this different graphs. They are clones. Okay, so we found out a list of the nodes neighbors and we pushed it in the vector, and yeah, we have it here. So we will just return the current here. Okay, that's how we made this copy, and it will recursively call all this, and it will do the thing. The recursion will do the rest of the thing. We don't have to worry about. We just need to worry about the small cases. Or you must return a copy of all the nodes in the original graph. So didn't we return that? Um, we return no DFS solve. If it is 0, let's start from the very start. Another graph, if node is null, then return null. If node's neighbors, okay, why is there 0 here? If node neighbors has a size of 0, then okay, yeah, it should work now. Yeah, it's done. Let's see. Yeah, it's correct. I only beat 6% if we submit it again. Yeah, okay. So next question is the rotting oranges. That's a famous question that we have three kinds of cells in this grid. First is 0 representing empty cells, 1 representing the fresh orange, and 2 representing the rotten orange. Every minute, every fresh adjacent orange to the rotten one gets rotten. Okay, in all the four direction. If there is a fresh orange adjacent to the rotten orange, it will be get rotten. It will get rotten. Okay, so we have to find the minimum number of minutes that it will elapse until no cell has a fresh orange. Okay, and if this is impossible, return -1. So if the fresh orange is out of the reach of all the rotten oranges, it will be -1. So what will be done is there is only one rotten oranges at this position. So at the first minute, it will rot this and this because these are adjacent to it. Second minute, these will be rotten by now. Okay, on the second minute, this will rot this and this, and this is also adjacent to this, so this will be the case. Okay, in the second minute, all these fives have been rotten after 2 minutes. Third minute, this will rot this. On the fourth minute, this will rot this. So in the 4 minutes, all the oranges will be rotten here. So this is the basically the flow of how the things are working here. So basically what we need to do here is we can keep how much time, 24 minutes we have done, so 6 minutes we have before half an hour. So yeah, so what we need to do is that for let's initially track down wherever the rotten oranges are. Once we know the locations of the rotten oranges and we know the count of fresh oranges, these are the two things we need to know: the positions of rotten oranges and the count of fresh oranges. Once we have them, then we will go to the each of the position of this rotten orange. We will go to all its four directions, and if we found any fresh orange, we will rot them, means we will put a value of 2 there. We will increment a minute and then we will go to the next position. Okay, and we will like make those positions also tracked. Okay, the French oranges which are just rotten, we will also save their position because they are rotten now and they are important to us, because in the next minute they might rot some other fresh orange. I guess it's clear now. So where we can start is that we can form a queue here. Yeah, let's try it. Q and Q. Q will be an integer or a pair of integer, right? We have to go for the positions. Pair of integer, and let's now int fresh, initially 0, int no yeah, int minutes 0 initially. Okay, now int n is grid dot size and m is grid 0 dot size. We are taking n and m, not m and n, so it's fine whatever we take. So we will run the loop for int I 0 to I less than n I plus plus, and for int j 0 to j less than m j plus plus. So if grid I comma j is 1, we will just do this. Else if grid I j is equal to 2, means it's rotten. So we will do what? We will q dot push the I and j. Okay, yeah, we got up to now. We have the counts here, and if there are no fresh oranges at the beginning itself, if fresh is 0, we will just return 0. Okay, apart from that, so now yeah, so while q is not empty, and there are two conditions now. If the queue is not empty and if the queue is not empty, and second condition that says fresh is not 0, until then we have to go. If fresh is greater than 0, we have to go. These are the two conditions, like queue must not be empty and fresh must not be less than 0. Until then this loop will go on. If any one of them is false, we will just get out of the loop. Now what will happen is that we will traverse the queue now, and sz is q dot size basically. Okay, now for this queue we will run a for loop, that for int I 0 to I, yeah, we can do this for auto it of this queue. No, we have to run a loop for its size only, I guess, right? So for int I 0 to, because one time I also tried this, but the queue size keeps increasing and this for loop will never stop, so that's also a problem for us. So int I 0 to I less than sz minus 1 and I plus plus. Actually it's equal to sz minus 1. Okay, so for this what we can do is we will take the front. So we will take int p as what? The q dot front. Now we will q dot pop. Okay, and what we will do here is we have the first and the second, we have the row and the column, right? So int row is what? P dot first and call is P dot second, or not dot. We have to do we access this. This is how we access the elements of pair. Okay, so we have the row and the column, and now for this row and column we have to go in all the directions. Okay, we have to go in all the directions to find out. Now how to traverse all the direction is, there's a way of doing it. Let's just define firstly all the directions. These are left, right, top and down. Okay, these are the directions. So let's how we can do this is that let's form a vector of pair int and this is the directions pair. Okay, and we will push 4 things in this direction, the 4 directions. Okay, so dir dot pushback, what? Dir dot pushback, we will push back all the directions, that is 1 0, and we will just copy this. Oh, it ran actually. No, we didn't intend it to. Yeah, dot is here. Dot must be here. I was wrong. That's actually done in, I don't know in which language it was done. Okay, so I is 1 0 and minus 1 0. Second direction is this 0 1 and 0 minus 1. These are the 4 directions actually. Okay, let's, yeah, fine. Okay, now this we have the row and column, so we will traverse through this directions, right? For auto IT of this direction, what we can do here is we will go to all the directions. And how are we going to do that? Yeah, our new row will be row plus is equal to the new cell we want to iterate is, let's say int I, no, int I not, int p is equal to what? It dot first plus the row. Okay, the row p is already defined, so we have to, let's say xy, it's not a problem, plus row, and y is equal to it dot second plus call. Fine, we have the new coordinate where we need to check. Okay, so if row is less than 0 or sorry, x is less than 0 or y is less than 0 or x is greater or equal to n, or y is greater or equal to m. Okay, or the grid x y is not equal to 1, is not even fresh, we will just continue. Okay, we will continue in that case, but if it's a 1, we need to make it rotten. So we will do what is that, we will do grid x y equals to 2. It will, we will make it rot, and we will append this into our, we will append this position into our q, that this is also rotten now, and it will be x and y, only if it's not, it was not rotten. Okay, and we will just do this also. Fresh count is decremented by 1. Okay, and every time we finish one iteration of this cube, full cube, we will just do this minutes plus plus. So we have to return the minutes ultimately. So minute will be returned only when c return fresh is 0, then return minutes, else return -1. Okay, let's try to run it now. Yeah, it's working fine. Well, yeah, it was good. So these were the four questions. This was, yeah, these were the 4 questions we had today, and all are done. So we are at graphs already, and once we complete the graph, DP will be our next thing. So that's all for today. We'll meet tomorrow again. Bye.